Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series, today we're going to see about the second normal form in the normalization under the database management system. So kindly watch my previous video. In that I have explained detailedly about the functional dependency as well as the normalization definition, what are the normal forms are available, that I have explained over that. So normally in our ER diagram, when we can say it is a good ER diagram means if we are converting our ER diagram into a tables, that particular table is in the first normal form means our design is very good manner. If it is not there means we have to convert our table into a 1NF. So while going for a second normal form, the rules to be, it must satisfy the two rules. One is it must be in a 1NF and also it should not contain any partial dependencies. Normally in our table, we are having two types of a key, two types of an attribute. One is a prime attribute, another one is a non-prime attribute. Prime attribute means the proper subset of all candidate key can be taken as a prime attribute. The remaining key attribute, we can take it as a non-prime attribute. If prime attribute can determine the non-prime attribute in the table means that type of dependencies, we can call it as a partial dependencies. A relation should not contain these type of a relation. Then only we can say this is a second normal form. For example, we have to check whether the given relation is 2NF or not. In this case, we are having a 6 attributes A, B, C, D. These are the functional dependencies. A tends to B, B tends to C tends to D, and D tends to E. By default, it is in 1NF because each and everything is depend on the another one only. It is having only a single value. It does not have any multiple value. By default, it is in 1NF. So second thing is the rule, whether it is prime attribute can determine the non-parameter. For that, we are going to calculate the closure. I think already I have taken how we can calculate the closure of an attribute. First, we have to take all the attribute of the list A, B, C, D. That closure, definitely it can be whatever the element present in the LHS through reflexivity property, we can able to write with. So we can say this is a super key. How I can say it is a super key means AF closure is a super key. I can able to identify all the attribute present in my relation. If it is a candidate key, their proper subset should not be a candidate key. So the proper should not have a super key. Then only we can say this is a candidate key. For that, we are calculating A closure and F closure. In this case, A closure, through that we can't able to identify the F. By using this thing, we can able to identify only F. So this is not a candidate super key. So AF closure is a candidate key. So A and F are the prime attribute because this proper subset, we're going to take it as a prime attribute. Non-prime attribute is B, C, D, and E, the non-prime attribute. Now we can check, is there any further candidate keys available in this relation? That we have to check. These prime attribute, either it can be present on the RHS or not. That we have to check it as. Here A is not present in RHS side and also F is not present in the RHS. So we can conclude that there is no more candidate key present in this particular relation. So we can conclude that A and F is a primary key and also B, C, D, and E is a non-prime attribute. Now we are checking, is there any partial dependency in this functional relation or not? How we can check the partial dependencies? If prime attribute can determine the non-prime attribute or not, that we have to check. See, through that, my prime attribute are A and F. So see here, this is my prime attribute. A is my prime attribute, B is non-prime attribute. So definitely this is a partial dependency. See here, this is non, this is non. This is also non, this is also non. This is non-prime attribute, this is also non-prime. So according to this relation, my first dependency A tends to B is a partial dependencies. So we can conclude that this particular relation is not in a second normal form because it can contain the partial dependencies. So how we can eliminate this partial dependencies means, so now we have to convert it into 2NF. In what case we have to convert means by using the decomposition only we can able to split our split our table. And also here we have, if you want to decompose our table, means that should be a lossless. If it is a loss, there is nothing present inside because my data is lost. So we have to conclude that my data should not be lost, and also it must be decomposed into a subtable for eliminating these type of dependencies. Similarly, I have given that one more example. You can work out this one. Relation A, B, C, D, their functional dependency. AB tends to CD, C tends to A, D tends to B. So you can work out this one. And also in my last example, I have quoted this one. Here we have to find the candidate key. While counting the candidate key, A plus is a super key and candidate key. Why I am saying this thing directly means here it is a singleton attribute. If a closure can have a single attribute, definitely that is a candidate key and super key. If it is my candidate key is a single attribute, directly we can say definitely that particular relationship in the second normal form. So in third normal form, what do you mean by that thing? Means the same procedure, but my non-prime attribute should not define the non-prime attribute. In this case, we have to, it should not contain this thing. If it is present, that is not in the third normal form. In my boys code normal form, it is the next version of my third normal form, because in the third, the candidate key, is there any overlapping in the candidate key? No? Definitely that is in busy enough. Up to busy enough, we can able to check whether it is a loss or lossless. After that, we can't able to check anything because decomposition preserving is supported only over that. That is not, that particular property is not supported for fourth normal form and fifth normal form. In my fourth normal form is the multi-value dependencies. So that is a particular relation should not contain the multiple value. If it is a joint dependency, that can be deals with the fifth normal form, that is also eliminated. That up to this only we are using a thing. Why we are normalize our table means nowadays, if you are going for a transaction or other security operation, definitely we need the normalized data. For that only we are using these different types of normalization. Thank you for watching my video.